In the summer of 1977, NASA launched the most daring, mind-blowing, and ambitious space missions in human history, Voyager 1 and Voyager 2. These two legendary spacecraft were custom-built to conquer the outer planets and plunge headfirst into the terrifying, freezing dark of interstellar space. Against all odds, these robotic pioneers are still alive today, screaming precious data back to Earth from the absolute edge of the unknown. They carry the very legacy of humanity into cosmic depths we cannot even hope to reach today. Right now, Voyager 1 is hurtling billions of miles away from Earth, deep in the interstellar void, with Voyager 2 pushing forward just behind it, past the outermost boundaries of our solar system. Our quest today is to explore the ultimate fate of these historic probes. What mind-bending scenarios await them in the deep cosmos, and where does our technology finally reach its limit? In this video, we will reveal the shocking current status and the dark future of the Voyager spacecraft. We are going to look at the terrifying end-of-life scenarios for these probes. Will they drift forever as ghost ships, or will they crash into an alien world? Voyager 1 and Voyager 2 were originally designed to exploit a spectacular once-in-a-lifetime planetary alignment. This cosmic phenomenon was so incredibly rare that it happens only once every 176 years. This perfect alignment allowed NASA to engineer a double-pronged assault on the outer solar system. Voyager 1 was sent on a high-speed trajectory to conquer Jupiter and Saturn, capturing groundbreaking data. Meanwhile, Voyager 2 took on the ultimate grand tour, flying past Jupiter, Saturn, Uranus, and Neptune. These metal beasts carried all our hopes and dreams, capturing revolutionary images that forever changed how we view our solar system. But their historic journey was far from over. After completing their primary missions, both spacecraft pushed onward into the deep, uncharted territory of interstellar space. In 2012, Voyager 1 made history by crossing the heliopause, becoming the first human-made object to enter interstellar space. But maintaining contact with these distant explorers is an absolute nightmare for NASA's Deep Space Network. Now, a devastating crisis is threatening to silence them forever. Spacecraft are rapidly running out of power. Their nuclear hearts, the radioisotope thermoelectric generators, are steadily dying. Powered by plutonium-238, the natural decay process is relentlessly draining their energy day by day, and there is absolutely nothing we can do to stop it. Ever since these generators were manufactured, their power has been slowly slipping away. We are witnessing the slow, tragic end of humanity's greatest cosmic messengers. The final hour is ticking for humanity's most distant explorers. Soon, the nuclear generators on board the legendary Voyager spacecraft will die, plunging them into eternal freezing silence. NASA estimates that these aging probes only have enough power to run a couple of onboard instruments until 2025. After that, the energy levels will plummet far below the absolute minimum required to survive. When this catastrophic power failure occurs, the Voyagers will go completely deaf and mute. They will no longer be able to beam signals back to Earth, nor will they be able to align their antennas toward our home planet. Every single scientific instrument will shut down forever. Yet, even as cold, dead metal, their journey through the infinite cosmic ocean will never stop. Deep in the dark, Voyager will carry our ultimate legacy, the Golden Records. This is the most precious cargo ever launched into space. On board both spacecraft, we placed golden phonograph records containing the diverse sounds of Earth, stunning images of our nature, our cultures, and the blueprint of human life. It even holds a cosmic map revealing our exact location in the galaxy, along with instructions on how to contact us. If an advanced, highly intelligent alien civilization ever intercepts these drifting relics, this silent mission will transform into the ultimate cosmic handshake. But what will happen to these silent messengers in the deep unknown? Will they survive the hostile environment of interstellar space? Some fear a catastrophic interstellar collision. However, because space is so unfathomably vast and empty, the chances of a crash are almost zero. If a collision ever does occur, it will happen millions of years in the future. Instead, an even more thrilling scenario awaits. Voyager might actually enter an alien solar system. In the cosmic future, the spacecraft will drift close to foreign stars. For example, in tens of thousands of years, Voyager will pass near the star Ross 248. While these distances seem impossible to us, on a cosmic scale, it is just a brief moment. Will these probes be pulled into the gravity of an alien world, or will they drift forever as the final ghostly evidence that humanity once existed? Could these silent metal beasts be our only hope of finding cosmic neighbors? Carrying humanity's ultimate message, the golden record, the legendary Voyager spacecraft drift through the freezing dark. They are our lonely messengers, searching for anyone or anything out there. But what if we are screaming into an empty void? The terrifying truth is, we might never make contact, and we may never know if we are truly alone. Yet, this daring mission represents our deepest desire to discover an alien civilization. We are desperately trying to bridge the cosmic gap, but the path remains a mystery. The golden record stands as a haunting reminder of our quest to connect. We refuse to accept that we are completely alone in this terrifyingly vast, infinite universe. Hurled into the unknown, these probes conquered the outer planets and plunged straight into the mysterious, uncharted realm of interstellar space. What started as a simple 5-year mission transformed into the ultimate test of human survival and ambition. Voyager pushed far past its expiration date, defying all odds, going where no machine has ever gone before. Today, Voyager 1 is a staggering 14 billion miles away, with Voyager 2 trailing close behind in the deep freeze. Surviving the brutal, radiation-heavy vacuum of deep space is nothing short of a miracle, showing us what is possible when we dare to dream. Against all logic, this ancient technology still breathes. Through mind-blowing software updates and genius engineering hacks, NASA has kept these historic explorers alive for over 4 decades. Today, we reveal the jaw-dropping strategies used to command these distant probes from billions of miles away. How does the mission team overcome failing hardware, dying thrusters, and freezing temperatures? It is a thrilling battle of innovation against the absolute limits of physics. As the Voyagers venture deeper into the dark, they carry our dreams into the ultimate frontier. This is a testament to human determination, proving that even with limited resources and extreme conditions, we can touch the stars and conquer the cosmos. The journey continues, and the mystery remains unsolved. Deep in the freezing, pitch-black abyss of interstellar space, 2 lonely explorers are doing the absolute impossible. The legendary Voyager spacecraft have survived for nearly half a century, defying every single law of space exploration. The secret behind this miraculous survival: a mind-blowing space-age nuclear battery known as the radioisotope thermoelectric generator, or RTG. While traditional spacecraft rely on solar panels, the outer solar system is shrouded in eternal darkness. Solar power is completely useless in the deep void. That is why Voyager was equipped with these revolutionary nuclear hearts. Inside each RTG, the natural decay of a highly radioactive isotope, plutonium-238, generates intense, blistering heat. Thermocouples then instantly convert this temperature difference directly into usable voltage. Because this process requires absolutely 0 moving parts, the system is incredibly reliable and virtually immune to mechanical wear and tear. Each Voyager spacecraft carries 3 of these powerful RTGs, packed with plutonium-238 oxide. When the mission launched back in 1977, these generators pumped out a formidable 470 watts of electrical power. But radioactive decay is an unstoppable force of nature. Over the decades, the plutonium has slowly decayed, and the power output has plummeted by a staggering 40%, leaving the spacecraft with just about 250 watts of electricity to survive. Faced with this slow-motion power crisis, the mission team has executed a masterclass in cosmic survival. To stretch every single watt, they have systematically shut down non-essential systems over the last 30 years. Ancient tape recorders and non-critical instruments have been permanently disabled. Even the vital heaters keeping the spacecraft warm in the sub-zero vacuum of space have been turned off. This extreme power rationing is the only reason Voyager 1 and Voyager 2 are still alive today, screaming invaluable scientific data back to Earth from the uncharted territory of interstellar space. Managing this delicate balance of heat and power in the freezing void is a monumental challenge. The spacecraft rely on advanced insulation and a sophisticated thermal control system to trap the remaining heat and keep the core systems from freezing to death. This is the ultimate triumph of human engineering, a relentless journey powered by nuclear fire. Managing the spacecraft's delicate thermal systems, instruments, and electronics requires a flawless, razor-thin balance. Extreme cosmic cold can instantly freeze and destroy critical components. Engineers even dynamically adjust the spacecraft's orientation, using the sun's faint warmth to shield vital instruments. It is a high-stakes, complex cosmic dance where every single move determines survival or total failure. Yet, against all odds, Voyager 1 and Voyager 2 continue their legendary journeys. Then, in 2016, the Hubble Space Telescope captured a ghost of light from the deep cosmos, a signal traveling from an object a staggering 13.1 billion light-years away, pushing our understanding of the Big Bang, which occurred 13.8 billion years ago. This ancient object existed at the very dawn of time, right at the edge of the Big Bang itself. But how reliable are our theories about the birth of the universe? To unlock this cosmic secret, scientists analyzed refined data from Hubble's deepest observations, diving into a treasure trove of information that represents 90% of the telescope's most intensive cosmic scans. When launched in 1990, this revolutionary telescope could capture 4,000 times more light than the human eye. Its ultra-sensitive graphite epoxy optical system detects not just visible light, but also near-ultraviolet and near-infrared wavelengths. Originally designed to peer 10 to 11 billion light-years into the void, scientists pushed its limits to an astonishing 13 billion light-years, staring directly into the infancy of our 13.8 billion-year-old universe. These ancient light rays have traveled across the vastness of space for eons. To understand this mind-bending connection to the Big Bang, we must look back to a historic discovery when Hubble detected GNZ11, a galaxy located 13.4 billion light-years away. This marked the closest humanity had ever come to the edge of the Big Bang. Studying this ancient relic reveals its chemical composition and extreme redshift, offering a window into the primordial universe. Shockingly, due to the rapid expansion of space, this galaxy has drifted to a staggering distance of over 32 billion light-years from Earth today, making it one of the most distant frontiers ever observed. Deep in the cosmic abyss lies the oldest, most distant monster galaxy ever detected by human technology, GNZ11. This legendary name was derived from its precise coordinate location within the Doc's North Galactic Cluster. Originally discovered back in 2016, NASA researchers analyzed data from the Hubble Space Telescope to spot this ancient titan. The space agency later revealed that this groundbreaking image was captured spectroscopically using Hubble's Wide Field Camera 3, combined with deep survey references from the Spitzer Space Telescope's great observatories. This cosmic relic is a direct portal to the aftermath of the Big Bang, showing us how the very first galaxies and cosmic structures assemble. By studying this region, scientists are peering inside the internal machinery of a newborn universe, capturing details that traditional ground-based observatories could never hope to see. Against all odds, humanity has pushed the limits of space exploration. Hubble has triumphed over extreme cosmic adversity, delivering high-precision optical data that has completely redefined our understanding of the universe. This is the golden age of space observation, capturing majestic views of the cosmos. We have discussed Hubble's difficult journey before, but looking back at this obstacle-filled path reveals a fascinating story. This journey started in the 1970s, when NASA first entered the fields of cosmology and astrophysics. This was the birth of the most complex space research project ever attempted. The dream was to build a massive space observatory capable of looking across vast cosmic distances, free from Earth's blurry atmosphere. It was a colossal, expensive gamble for the government. But in the summer of 1993, during a high-stakes spacewalk, brave astronauts executed a historic repair mission, finally giving Hubble its legendary crystal-clear vision. This legendary telescope went on to rewrite the cosmic history books. First, it answered the ultimate question: how old is the universe? By analyzing the complex physics of massive galactic clusters, scientists unlocked the age of our cosmos. This revolutionary method required ultra-precise measurements of distant astronomical objects, and Hubble delivered the crucial data, revealing that our universe was born exactly 13.8 billion years ago. Second, it measured the terrifying rate of cosmic expansion. While the Big Bang Theory predicted an expanding universe, Hubble provided the hard evidence, solving one of humanity's greatest cosmic mysteries. Imagine a cataclysmic explosion 13.8 billion years ago. The Big Bang sparked the violent birth of our universe, launching everything into a wild, endless cosmic race. Even now, at this very second, stars, planets, and entire galaxies are hurtling through the cold, dark void of space. Matter is screaming away from us. But here is the mind-blowing question: how fast is this cosmic escape actually happening? At what terrifying rate is the fabric of space stretching? To crack this ultimate mystery, scientists turned to the legendary Hubble calculations. The shocking truth they uncovered: the cosmos is tearing apart at a staggering speed of roughly 70 kilometers per second per megaparsec. That means if a galaxy is just 1 megaparsec, about 3.26 million light-years away, it is flying away from us at 70 kilometers per second. Double that distance to 2 megaparsecs, and it flees at a jaw-dropping 140 kilometers per second. Understanding this expansion is the absolute key to decoding the cosmos. But the plot thickens. Peer deep into the void with the Hubble Space Telescope, and you confront monstrous black holes and the invisible grip of dark matter. These cosmic titans shape entire galaxies, holding the secrets of creation and destruction. For ages, we believed understanding this was simple. We thought the Hubble constant would solve everything. But instead, it has triggered one of the greatest scientific crises of our time. A massive paradox that threatens to rewrite physics. What is the universe trying to hide? What secrets lie buried in the deep space data? Every time astronomers try to pin down this crucial number, the universe throws a curveball. The numbers just don't match. This has sparked the ultimate cosmological mystery, leaving the world's greatest minds completely baffled. Yet, the relentless hunt for the truth continues. To understand this crisis, we must look at the math. The Hubble constant connects two vital cosmic forces: how fast a galaxy is rushing away and how far it is from us. By measuring a galaxy's speed in kilometers per second and its distance in megaparsecs, we get this magic ratio. If the constant were, say, 100 kilometers per second per megaparsec, it would mean the farther out we look, the faster the universe is ripping itself apart. Solving this equation is the holy grail of astronomy. It is the master key to decoding the birth, life, and ultimate doom of our entire universe. Unlocking the ultimate rate of cosmic expansion, the Hubble constant presents a mind-bending challenge. To map the vastness of space, astronomers rely on cosmological redshift and the apparent brightness of distant stars and galaxies. By measuring how light stretches and fades across the dark void, scientists calculate the staggering distances to these celestial bodies. Historically, Edwin Hubble shocked the scientific world by calculating this expansion rate at a whopping 500 kilometers per second per megaparsec. To reach this groundbreaking conclusion, Hubble analyzed the distances and velocities of 46 different galaxies. Yet, modern science has revealed a shocking truth. His original calculation was off by a staggering 7-fold, being 7 times larger than today's accepted value. But how do we measure even deeper into the cosmic abyss, far beyond 50 megaparsecs? Enter the universe's ultimate standard candles, Type 1a supernovae. These cataclysmic events occur in binary systems when a superdense white dwarf star pulls material from its companion, triggering a colossal thermonuclear explosion. The resulting flash is so blindingly intense it can be seen across billions of light years, acting as a cosmic lighthouse to measure the true scale of the universe. To harness these cosmic explosions, the Hubble Space Telescope launched an ambitious campaign to study these distant supernovae and pin down the exact rate of expansion. But instead of solving the mystery, it sparked a crisis in cosmology. Recent measurements calculated the Hubble constant at 74 kilometers per second per megaparsec. Yet, conflicting data from the early universe insists the value is only 67 to 68. This glaring discrepancy has left the scientific community in absolute chaos. Now, a thrilling new era of discovery begins. To resolve this cosmic clash, humanity is turning to its most powerful space observatories. We pit the legendary Hubble Space Telescope, which revolutionized our view of the cosmos for over 3 decades, against its formidable successor, the James Webb Space Telescope. By comparing the capabilities of these two engineering marvels, we can finally hope to decode the ultimate secrets of our expanding universe. The Hubble Space Telescope was a monumental triumph in human history, an engineering marvel that reshaped our understanding of the cosmos. As the world's very first space telescope, it holds a legendary status that may never be eclipsed. For decades, Hubble was a relentless cosmic pioneer, decoding universe-shattering secrets and answering humanity's oldest questions. But now this aging titan is ready to pass the torch to a mind-blowing successor. Enter the James Webb Space Telescope. Stationed a staggering 1.5 million kilometers away at the mysterious Lagrange point L2, this machine is poised to peer into the absolute dawn of time. Today, we put these two cosmic giants head-to-head in an ultimate 10-point battle to see which telescope reigns supreme as the true king of space exploration. While the legendary Hubble was constructed by aerospace giant Lockheed Martin, the groundbreaking James Webb is a historic mega-alliance between NASA, the European Space Agency, and the Canadian Space Agency. Launched on a thrilling Christmas Day in 2021, this next-gen marvel was brought to life by Northrop Grumman and Ball Aerospace, culminating in decades of intense development. Looking at their physical presence, Hubble is a beast, stretching over 43 feet long and weighing a massive 12,000 kilograms, comparable to a school bus. Its primary eye is a circular 7.8-foot mirror flanked by 2 giant solar arrays. But James Webb completely shatters these scales. It features a jaw-dropping, gold-plated primary mirror spanning over 21 feet, and a colossal sunshield the size of a tennis court, measuring 70 feet long. Yet, incredibly, this giant weighs just 6,500 kilograms, nearly half the weight of Hubble, making it as light as a commercial truck. Let's dive deep into the mind-bending technology powering these cosmic eyes. 3 decades ago, Hubble revolutionized astronomy by capturing the universe in stunning visible light. But James Webb is a completely different beast, utilizing ultra-sensitive infrared technology to pierce through cosmic dust. With a field of view that dwarfs Hubble, Webb can see the unseen, giving it a massive victory in raw visual power. There is no doubt that Webb's state-of-the-art instruments deliver unprecedented precision, capturing deep-field images that make Hubble's best shots look like ancient history. While Hubble relies on classic cameras and spectrographs, Webb utilizes 4 revolutionary systems, including advanced optical elements and an integrated science module, protected by its massive sunshield. The cosmic crown is officially up for grabs. By stripping down unnecessary payloads, the revolutionary JWST and Hubble telescopes maximize their operational power, delivering mind-blowing, crystal-clear images of the deep cosmos. But space is a brutal environment. The ultimate challenge: mission duration. Years of intense preparation lead to a high-stakes race against time, where a single failure can destroy decades of work. Decades ago, NASA launched the legendary Hubble Space Telescope, embarking on a lonely journey into the dark unknown. For years, it stood alone as our eye in the sky. Now, a new era of space exploration has arrived. Get ready for the most mind-bending revelations in human history. Hubble didn't just observe the universe, it completely rewrote our understanding of reality. It unlocked deep cosmic mysteries, answering questions we didn't even know how to ask. From mapping distant galaxies and hunting for alien life on mysterious planets, to decoding the fundamental laws of physics, Hubble kickstarted the revolution of modern cosmology. Even when this iconic telescope finally goes dark and dies, it will leave behind an unmatched legacy. Now a new titan enters the arena. While the future remains unpredictable, one thing is certain: this groundbreaking technology has forever changed our place in the universe.